If atoms exist in patterns in space, we should somehow be able to measure their size.
I think I'm going to ready to make noodle right now.
We approach the division of matter by the attractive process of halving and halving and halving it again.
Okay. 1 time becomes 2 noodles. 2 times becomes 4 noodles. 3, double. 10. 11. 12. That is 4,096 strands. Look at that. Wow.
12 foldings produced 4,096 fine noodles.
Yeah.
And if Chef Mark could have stretched the dough 30 more times, the noodles would have reached atomic thickness.
That's called dragon spare noodles, like a human here. It's very fine.
A simple outdoors experiment allows us to see how thin we can get matter to be. We've chosen a pleasantly breezy day at the banks of a pond. Okay, looks good. Our equipment couldn't be simpler. Some olive oil and a set of measuring spoons. 1/4 teaspoon goes onto the water. The oil spreads of its own accord. As it thins beyond visibility, the oil remains detectable by the action of the wind. The wind ruffles the water where there is no oil film, but where oil is present, the surface is more mirror-like. The oil film spread, first fast and then very slowly, and then it seemed to come to a stop. And I would reckon that the area it covered was about 10 yards by 20 yards, or 200 square yards. Now, a square yard is 3 feet by 3 feet, so about 10 square feet. A physicist's arithmetic should not be more precise than his eyeball measurements. And that would give us about 2,000 square feet of film. The 2,000 square feet came from a spoonful less than 1 inch across. The oil film grew 1,000,000 times larger than the spoon. It must also have grown 1,000,000 times thinner. So I would say that the film we're looking at is, on average, when it stops spreading, about 1/5,000,000th of an inch thick. That's 100 or 200 times thinner than the gold beaters make their gold leaf, and it's a great deal smaller than Chef Mark's wonderful way of drawing out fine noodles. It's not yet the size of an atom. Oil is not just atoms, it's a complicated compound. But it must have some cluster of atoms, and we know that that little cluster, whatever it will be, is not bigger than a 5,000,000th part of an inch. Certainly, atoms are no larger than the thickness of the final film of oil. We are close to knowing the size of an atom.